See, students, you are knowing the history of magnetism, the interesting stories of magnetism, but how it originates in the material that we are going to study in the topic magnetism. For origin of magnetism, there are different conditions. One condition that is motion of electrons. There are different motion of electrons. One that is orbital motion, that is spinning motion of electrons, and nuclear spin motion. In orbital motion, the electron revolving about the nucleus in circular orbits. During this, there is a formation of pair of electrons in opposite situation, and these orbiting electrons developing the magnetic dipole moments. These magnetic dipole moments give rise the magnetism. Secondly, the electron spin about its axis, and this spinning motion, if it is in clockwise direction, then it is giving S pole. If it is anti-clockwise direction, it is giving N pole. In this way, the spinning motion of electron also gives the origin of magnetism. In similar way, the nuclear spin, it is very negligible value to give the magnetism in case of material due to the nuclear spin, but nuclear spinning motion also generates the magnetism. The second condition, that is atomic magnetic moment. The atom itself with minimum 2 electrons or further, it is giving the magnetic dipole moments. These magnetic dipole moments are aligned in different directions, or in certain cases it is in typical arrangement of domains. These atomic magnetic moments are contributing the better quantity or much quantity in case of magnetism. Further, the elementary magnetism of electron, that is in terms of Bohr magneton, it is the specific value introduced in terms of the value, say mu is equal to mu b, that is for magnetism it is Eh divided by 4 pi m. This value, it is generated according to Bohr theory of motion of electrons. This is the typical case. In this way, the three conditions explain better way the origin of magnetism. Referring to the magnetism, different terminologies are to be known, and this is dependent on magnetic lines of force, magnetic tubes of force. The magnetic tubes of force passing normally through given surface area, that is giving the magnetic flux. This magnetic flux giving rise magnetic induction, further magnetic field strength, magnetization, etc. This magnetic flux, it is per unit area of a given surface, that is giving magnetic induction B. This is expressed magnetic flux in Weber, and the surface area in area, that is a meter square. Therefore, it is expressed in Weber per meter square. Second, magnetic field strength. Magnetic field strength is force expressed by unit north pole at a given point in the magnetic field. That is known as magnetic field strength. It is represented by symbol H and expressed in terms of ampere per meter. Whenever the magnetic material is to be converted into a magnet, then the process of magnetization is necessary. In this magnetization process, there are different ways to magnetize given material keeping in strong magnetic field. And in this, the magnetic moment per unit volume, magnetic moment developed per unit volume in the material, that is magnetization or intensity of magnetization, and it is expressed by symbol M, and in the unit again ampere per meter. This magnetization again determines what amount of magnetic energy is used for magnetization, what amount of magnetic energy is lost, that is giving the property magnetic susceptibility. Magnetic susceptibility is the magnetization produced in the material per unit applied magnetic field. It is represented in this way: magnetization per unit applied magnetic field M divided by H. This is the ratio of similar quantities, therefore it has no unit. This magnetic susceptibility determines the magnetization ability of the material, whether it can be used for strong magnetic material or weak magnetic material. The magnetic susceptibility is the specific property. In further way, the magnetic permeability. It is ability of the medium to generate magnetization or to convert the material into magnetic material. And this magnetic permeability is the ratio of magnetic induction B to the magnetic field strength H. And It is B divided by H, represented by symbol B. This is specific property for the particular material. Again, it has no unit. If it is free space or vacuum, its value is mu 0. Magnetic permeability of vacuum of free space, it is mu 0 equal to 4 pi into 10 raised to minus 7, say Weber per ampere meter. This is the specific quantity. Dependent on this, the other properties can be represented. The relative permeability of given material, that is expressed in this way. The relative permeability mu r is equal to mu divided by mu 0. Mu 0 is permeability of free space. These terminologies are needed to study further properties of magnetic materials.